Hey there, young explorers. Have you ever wondered, what's underneath our feet? Is it just more dirt, or does the Earth have secret layers hidden inside? Well, get ready, because today we're digging deep, literally. We're exploring the layers of the Earth, from the thin crust where we live, down to the blazing hot core that powers volcanoes. Let's journey to the center of the Earth. Why is this important? The Earth's layers affect volcanoes, earthquakes, and mountains. Understanding the Earth's structure helps us predict natural disasters. It's how scientists learn about Earth's history, even how continents move. Grab your hard hats and let's start digging. The Earth is like a giant layer cake. It has 4 main layers, each with different materials, temperatures, and pressures. The 4 layers of the Earth. 1. Crust, the outer shell where we live. 1. Mantle, the thickest layer with hot, flowing rock. 1. Outer core, made of liquid metal, super hot. 1. Inner core, a solid metal ball at Earth's center. Fun fact, the Earth's core is hotter than the surface of the sun. Activity, cut an apple in half. The skin is like Earth's crust. The white part is the mantle, and the core is, well, the core. The crust is the outermost layer of the Earth. It's where we live, walk, and build cities. It's the thinnest layer, only 5 to 70 kilometers thick. Compared to the whole Earth, that's like an eggshell. 2 types of crust. Oceanic crust, thinner but denser, made mostly of basalt. Continental crust, thicker but lighter, made mostly of granite. Fun fact, the tallest mountain, Mount Everest, is part of the continental crust. It's over 29,000 feet high. Challenge, find a rock near you. It could be part of the continental crust. Beneath the crust, we find the mantle, Earth's thickest layer. About 2,900 kilometers thick, made of hot semi-solid rock that slowly moves like taffy. This movement causes earthquakes, volcanoes, and mountain building. The mantle is divided into 2 parts. Upper mantle, lithosphere plus asthenosphere, moves tectonic plates. Lower mantle, hotter but still solid rock under high pressure. Fun fact, the mantle is so hot it melts rock into magma, which erupts from volcanoes. Activities stretch and pull slime. That's how mantle rock slowly moves over time. Now things get really hot. Welcome to the outer core. Made of melted iron and nickel, over 4,000 degrees Celsius, 7,200 degrees Fahrenheit. Creates Earth's magnetic field, protecting us from solar radiation. Fun fact, without Earth's magnetic field, we'd be hit by harmful space radiation. Challenge, grab a magnet. It works because of Earth's metal core. We've reached the center of the Earth. Meet the inner core. Solid metal, iron and nickel, hotter than the surface of the sun. Spins slightly faster than the rest of Earth. Fun fact, even though the inner core is hotter than lava, it stays solid because of the intense pressure. Activity, hold a heavy object. Imagine the pressure at the Earth's center is millions of times stronger. If we've never been to the center of the Earth, how do we know it's there? Seismic waves. Scientists study earthquake waves to see how they travel through layers. Volcanoes. Magma from the mantle gives clues about Earth's interior. Meteorites contain iron and nickel, like Earth's core. Fun fact, the deepest hole ever dug, the Kola super deep borehole, only reached 12 kilometers into the crust. That's like scratching the surface of Earth's layers. Activity, drop a ball into water and watch the ripples. This is similar to how seismic waves move through Earth. Wow, we just traveled through Earth's layers. Let's do a quick recap. Crust thin, outermost layer where we live. Mantle, thick, hot, moving rock that shapes Earth. Outer core. Liquid metal creates our magnetic field. Inner core, super hot solid metal ball at the center. Now here's your challenge. Find a rock near you and think, could this be part of the Earth's crust? Let us know in the comments. And hey, if you had fun today, don't forget to like, share, and subscribe to School Subjects Online for more awesome science videos. Until next time, stay curious and keep exploring.